Hi everyone, Audrow here. In this episode, I share with you several interviews that I recorded at ROSCon 2024 in Denmark. For those of you who don't know, ROSCon is a global robotics conference hosted by Open Robotics that brings together a lot of the robot operating system, or ROS, community. It's super fun and a great way to meet a bunch of the people building the future. The first interview is with Marcus Scheunemann, who is the head of autonomy at Dexory. Dexory is based in the UK and is one of the most promising robotic startups I've talked to in a while. They just had their Series B and are scaling rapidly. The most interesting part to me is that they put a huge amount of effort into their testing infrastructure, and that seems to be one of the reasons they're able to scale so fast. The second interview is with Christine Fraser, who's the CEO and founder of Asimovo. Asimovo is making it easier for teams to make robots by making it easier to have repeatable developer setups. They build everything on Kubernetes, which gives them a lot of advantages that I think we don't often get in robotics. You may want to use it yourself. Finally, the third interview is with Angelo Corsaro, who is the CEO and CTO of ZettaScale Technologies, and it's about Zenoh. If you were at ROSCon, you'll know that Zenoh was the big topic for the conference. If you don't know, ROS2 uses Data Distribution Service, or DDS, as its middleware. But DDS wasn't designed for robot applications, and there are some rough edges, like there may be a lot of initial configuration to get it working, and it doesn't scale great for multi-robot systems. Zenoh works to address the rough edges of DDS, and will be the default middleware for a future ROS2 release. You can already use it if you want to build from source. This was really exciting, and it was great to hear about Zenoh firsthand from Angelo. I also recorded another 3 interviews that couldn't fit into this episode, so they'll be published on X and YouTube in the next weeks. Grab a snack, get comfortable, and I hope you enjoy. All right, would you introduce yourself?
Yes, of course. I'm Marcus Scheunemann. I'm the head of autonomy in Dexory. And there since 3 years. We are in the logistics space and building this kind of robot since 2 years now. So this guy is actually a year old. He kind of released it when it was at the New Orleans ROSCon. And yeah, that's what it is. Yeah.
So tell me a bit about the company. How large are you guys? What stage of funding are you at? Like all the details.
What's the size? Like 2 years ago, we didn't have a robot. We had an idea. We wanted to go into the logistics space. We wanted to revolutionize, disrupt, how you say it, the logistics sector and the inventory management. So no robot 2 years ago. Last year, March 2023, in March, we had our first deployment to a warehouse with the first robot. We had 1 robot, we were 20 people, something like this. Now, this time around, we are 200 people. We have built
so exciting.
More than 90 robots. We are building 3 robots per week of this size.
Wow.
And deployed in 3 continents, 8 countries. So yeah, it's been a ride.
And you just got your Series B funding, if I understand correctly? That's so exciting, because that's a very hard one for robotics companies, I hear. Because you have to be coming into the scaling phase for investors to want to do a Series B.
100%.
And you are there, you're starting to scale, and you've come very quick. 2 years, you say, from no robot to robot.
Yeah,
you know.
I mean, it's a constant fight with challenges. Everybody who went to the scale-up knows that, right? But that's also when the fun starts, because I loved working on robots, I loved working on prototypes, but now actually the whole vision I always had, and how do we have to design code and how do we have to test the robot to bring it to scale and productionizing it, now I can really unfold it and actually make it happen. So for me personally, it's a challenge, I love it, but it is a ride. And you are absolutely correct. Series B is hard, because currently investors are cautious, let's put it that way. They want to see some multipliers, they want to see some revenue.
Yes.
And creating revenue fast is a challenge. So you have to get out with the robots very, very early, create revenue, and then multiply.
Definitely. And because the create revenue fast is kind of the key part to me, because many companies, if they are creating revenue but slowly, it might not make sense as a venture capital company, because it's not going to get the returns they want on the timeline they want. And it's exciting that you guys are so quickly creating value so much that you're scaling It's unbelievable to go to so many robots so quickly. And
thank you for that. I mean, it's really appreciated. I actually get a little bit goosebumps there than thinking about this. Sometimes we look at our venture, our journey, and it's still a bit unreal.
Yeah.
But I tell you two things there. Like, the pace is for us absolutely essential. So we need to be fast in the space because, yes, we found a solution to a problem that exists, but I must think someone else is also working on it. So the pace is essential. So we need the money, we need the venture capital, and we have to create obviously this traction there. And yeah, that's why we need the revenue. And the second part is, and that's probably interesting for the listeners, I was very skeptical to do that, to be fair. So I learned a lot from my founders.
to scale quickly?
Or to move to the customer fast, let's put it that way. So there's a robot you have, and you have a vision how accurate and how nice it should do everything. So we didn't compromise on safety. For a matter of fact, we always tested the safety inside out. That's fine. But I thought, like, man, we can do a bit more on the performance side. But I learned then from my founders, they were like, no, Marco, let's push it out to a customer and learn more. And I liked the learning more a bit, but I was also like, is there not a risk, right? But as long as you keep it safe, you want to be as fast as possible at the customer. The learning we created made us just double the pace. It was insane.
Oh, I bet.
Yep.
Yeah, because if you're not, you're iterating, you're learning lessons, you're actually figuring out what the customer wants and how to charge them and what kind of things are sticking points for your technology that you have to focus on.
Exactly that.
Yeah, getting out there early makes a lot of sense.
And you have assumptions that are wrong. And as an engineer, you see maybe the problem a little bit different than your customer sees the problem. Yeah. So you get the learning in and you adapt and you work on the right stuff early on. So that's the important part. And I think... it might sound arrogant, but I think this one we actually did very, very well. That's why we are so fast currently.
Do you guys I feel like getting to Series B is a huge milestone for robotics companies, and most fail before it.
Yes.
And so, like, a little arrogant. Perfect.
Okay, well.
You deserve it. Really kind of thing. Yeah. So the company, it sounds very promising what you guys are doing. Tell me a bit about the problem you're solving and what your robot, like the approach that your robot is taking.
So the problem space is lost inventory pretty much. So like the customer wants to track ideally very fast.
How large of a problem is this? Because I've heard that it's like half of inventory or something goes missing or some like crazy numbers.
Yeah.
How significant of a problem is lost inventory?
Well, I'm not a salesperson here, right? So I don't know exactly what we are saying normally. But when I speak to the customer on the floor space, depending on the customer, if they have servers racks or depending on one value of an item, right? Like one pallet can be millions worth. If you just place it into the wrong aisle in a warehouse that is 100,000 square meter big.
It's good for it lost forever.
It is lost forever, yes. I was at the customer side where we found a box which was 10 years old because they doubt our results. They were like, no, that can't be the case. This can't exist anymore. But we found it and they're like, wow, that's old. So that gets lost. There are two ways to bring value. It's either high good items that are getting lost and which is just like they're not there on time anymore, or just in time in general, right? If you have to stock a truck which is going to the facility for production, and you don't find everything just in time, then you have a problem. You have a lot of costs to bear for the person you don't deliver the right goods to. So these are the two main points. Yeah.
Mm-hmm. Okay. And so to manage inventory, your robot has this large telescoping set of sensors.
Yeah.
So it can scan all the aisles that have stacks and stacks and stacks of items.
Yeah.
Right? On pallets. Okay. So that's the general approach. Tell me a little bit about the robot.
Okay. Well, exactly. So we have this tower. We wanted to go with a tower to be fast, right? So what we can create, and here again, we learn going early to the customer. So our first customers had smaller warehouses. I'm talking like 20,000 square meters.
Seems enormous.
Yeah.
Yeah.
And but we thought it is enormous. I mean, like, wow, how can it set speed bigger? But nowadays it's 10 times bigger where we are going.
Wow.
And we anticipated larger warehouses. We just were not sure. But this one is like, you have a lot of speed. We can, with a tower, going like with a full scanning phase along a rack, with 1.5 meter per second, you can scan up to 15,000 locations per hour, which means like most warehouses have like 100, 200,000. So we manage in less than a day to scan also the largest warehouses, which creates exactly the value we are talking about.
Yep.
It's a real-time, almost of what we consider in warehouses real-time digital twin of their assets. It makes them much more productive. So that's why we went for the tower. We pretty much see there.
Mm-hmm. For the speed and everything like this.
Also speed, but there's also an element. It kind of emerged of another thing as well. So we came from retail. We had a really cute, my favorite MIM robot.
So like grocery stores or something like that?
Exactly, grocery store, electric stores, and it was then checking stock and inventory pretty much of the store. There are a few companies doing that.
Yeah.
And this robot had a similar scanning phase as you see there. But you must imagine that this robot kind of is one of the sections you see in this tower.
Yep.
So this robot here, this example, has 6 sections. And you can imagine there are kind of 6 MIMs. And so we could use the old business logic of our robot and just reuse it for this robot, scale it up to 6. And that made us incredibly fast in the beginning. So this knowledge, we could just scale up this.
Oh, yeah. And are you using ROS, the robot operating system?
Yeah. Big AutoCAD, we are also a sponsor, of course. And we use a lot of open source software. And we contribute back to us. So like, it's very important for us to have the knowledge of the community, to move fast, see where they are going and give back. So what we are using is ROS 2, Iron currently. And
so cool.
We want to switch like already yesterday, but sometimes there's crunch time. So yeah, obviously, because end of support coming for Iron. And we are always on the latest release. And we will actually talk tomorrow also about that, why this is important for us.
Oh, yeah. I like that. Because it seems like a lot of companies, they will be on, like many companies are still on ROS 1.
Yeah.
And like, so I'm the ROS boss for Humble version. But it's like, so a lot of companies, they'll pick one and they'll stay on it versus keep upgrading. And I guess it's kind of like you have a little bit of pain every time you're upgrading to the new distribution. But then you, over time, you're eating that pain slowly as opposed to having it all at once when you switch from ROS 1 to ROS 2 or something like this. I like that you guys are doing that.
No, that's perfect. I mean, there's a motivation element you have to have. Like, so your company must embrace robotics in their core.
Yep.
And when they do that, and you can give them easily the idea of maintainability and being more feature ready, is our central bit. So we have to update. So we have to give the customer the best stuff that is there because they may see it somewhere else. We are robotics as a service.
That's an interesting idea. Okay.
We are not selling the robot. We are just putting the robot there, and we are selling the customer data. And to be always on the forefront of the technology, we are also on the forefront and with updating with ROS 2. But I give you that, like other companies run ROS 1 and the switch is just hard.
Yes.
And I think one of the biggest problems is that you need to invest a lot of time into the right testing infrastructure to understand when you do the switch that you can quantitatively say that you don't break anything your customers had before. And this is horribly expensive. And we are doing this. So like we are investing a lot in that. I never call it testing when I talk to anybody. I call it like maintainability insurance.
Why?
Right? That you can. It's easier to sell internally. Because that's a money equivalent.
No one wants to pay for testing. It's
no, literally not. Testing is like
so maintainability or something like that.
And being feature ready, creating more features easily, time to market. We are reducing any time to market for each feature. This is how I communicate it.
I love it. I think that's a really smart approach. So with that, what advice do you have for someone who wants more testing at their organization and this kind of thing? Changing the words a little bit, maintainability seems like a good one. But like imagine someone in a robotics company where they want to increase the testing, but it's harder to sell management on it because they want new features or something like this. Like how would you frame it, or what are your thoughts on making that more likely to happen?
It's the time to market is still one of the key bits, because if you can ensure that a new feature is not breaking the old stuff which is with customers, and especially if you update your whole fleet, what we are doing as a robot as a service company, then you to decrease this time, you need the testing resources. So, and that is kind of the metric I'm using mainly to communicate that. Other advice, it's hard. So like, I think the biggest challenge every robotics person in a company is facing is that we are still in the very early ages of robotics, I think.
Very much.
And the complexity that it's different than software, like handling a whole electromechanical system with software, it's usually not that central in companies. And you have to make somehow sure that this is a central part where you can drive decisions.
I don't fully understand. What do you mean, the electromechanical? Like actually testing on a physical robot? Is that what you mean? Or what do you mean?
No, that's for sure. No, I'm leaving the testing part here. It's not about like embracing that robotics is hard. I think that is rarely the case. So,
what do they do? They try to abstract it and stay away from the hardware? Or what did people do now?
Yeah. No, so the way I try to get there is... when you have a software-driven approach, you are not tackling the problems at their core. So like, when you say testing in software, I mean, you can automate this, you create unit
You run it in simulation.
Exactly. You have specific processes you go through, like you have a QA maybe, and they just do like, I use numbers from 0 to 100 and then I check it, right?
Like normal
obviously it's more
software testing. Yeah.
Exactly. It's more complicated, but in the gist there's like, I take crazy numbers and then let's see what's happening. With robotics is crazy, right? So there can be environmental factors, like your sensor over time gets a bit untidy for some reason, or like needs cleaning, and then the magnitude of the error changes. So you have to take all these bits into account and create constant learnings and monitoring to be adaptable. And to create time for that, people have to embrace that this is complex, right? And I think a lot of the methods done for companies are very software focused. So a lot of templates we are using is like, we do it in software this way. It should be done in robotics this way. And we kind of have to reinvent this wheel. Yes? And there needs to be something different. And the advice is like for companies, I would say you have to embrace the core complexity. So you have to listen to your robotics people because they usually do know where the pain points are. And if you ignore that and think like, well, just test it with some numbers, that's not how it works.
Okay. Where do you guys think you're headed in the next, say, 2 to 5 years? I know you're scaling like crazy, but what do you think projecting out 2 to 5 years?
Yeah, so pace is for us of utmost importance. To create the right revenue, to get more funding, etc. So currently we have 5 times the robots than in last year, right?
That's wild.
It is. And we have the right infrastructure in place to scale this further. So pretty much, personally, I think sky is the limit. I never thought about anything longer than a month ago. Month forward, months ahead, yes, exactly. Because that's the nature of a scale-up. Yeah. So next ROSCon, I would assume we have 1,000 robots out.
Wow.
Yeah. I mean, that's a...
1 year, yeah. 1,000. Yeah, because you 5 times in the last year, so another 5 times. That's crazy.
That's very ambitious, to be fair. But yeah, we have already 100 out. We want to produce six a week. Yeah, let's see.
Okay, yeah, the manufacturing might be the difficulty.
Manufacturing is like there's always a new challenge while you are scaling, where you have to further optimize.
Because you keep hitting bottlenecks, basically. You keep moving from bottleneck to bottleneck.
Correct. And you learn, exactly. It's the same point again, right? So you learn while you are doing it. So we are not there for 5 years yet. You don't have the full picture of maintainability and reliability of a decade. You just have it for 2 years, pretty much. So there's still a lot to learn. So yes, we probably have let's correct me there. Maybe it's a 600 robots build or something. And
Bill, it's so exciting. It's a lot of robots.
It is.
And so quickly too.
Yeah, thank you for that. I think so too. It's that's a roller coaster, to be fair. It's fast.
Oh yeah. Well, great talking with you.
Thank you so much, and have a great one. Enjoy the conference.
Yes, definitely. Here's my conversation with Christine Fraser from Asimovo.
Hi.
Would you introduce yourself?
I'm Christine Fraser. I'm the CEO and founder of Asimovo. And Asimovo is a RoboDevOps platform. So it's a development platform for developing and testing robots.
Oh, yeah. So tell me a bit about, like, what do you guys offer, I suppose, with your developer platform?
So here, basically what we find was that if you're developing complex robotics behaviors or working on complex robotics tasks, normally you're not working alone. You're working as a team, or most autonomous behaviors, you're now wanting to kind of also collaborate, for example, with machine learning experts or data scientists or AI tools or even test engineers. So what you want is to be working on all the development and robotic tasks, but doing it within a team. And what we found was that the tools weren't really compatible with doing that easily. And also, as you do more and more simulation for building complex behaviors, you need more compute power, and your laptop runs out at some point.
Yeah, very much.
So these were the two big things that we identified early on. Okay, it needs to be a lot more collaboration and less developing only in silos. And you need to basically to connect whatever compute you want. And that's kind of where we started. So we've developed the biggest sandbox you could create, where you can have a digital source of truth for your whole project. Everyone can work on that and populate it with the same assets that you're all developing. And then you can choose to work in your integrated development environment, either on your local machines or in the cloud, or we can connect to on-prem servers or supercompute as needed.
Wow. Okay. So that seems like quite a lot that you guys are doing, like many different permutations and permutations of things that you may be doing for customers. Has that, you've kind of iterated to all that, whereas some people want on-prem devices, some people, so how does that, like, tell me a bit more about that whole journey of getting to all these different solutions, and then also how you have a common part with all that. Because it sounds a little bit like you could be spreading yourself thin, supporting all of these different things. But tell me about that.
It took us quite a long time to build our MVP. Let me put it that way. This wasn't a quick app that you just create.
Yep.
So we're talking about serious infrastructure that we're building. So we use Kubernetes so we can connect that to any compute.
Wow.
We use a lot of containerization, but often in a project you're looking at something that's very complex. So you're talking about, like, the total toolkit can quite often be between 10 and 20 gigabytes. So, and then you're collecting robotic data that's large files that aren't easy to upload into Google Drive or whatever. So what you find is that actually the tools that you need for robotics are professional level tools, and they don't really exist. So rather than reinvent the wheel or develop lots of complex behaviors, we've focused on developing the toolkit needed to do the job. And how can we professionalize robotics development? And if you can enable teams to work together, then projects can be run faster. And projects or products or robots that are developed by multidisciplinary teams will be stronger as a result, rather than developed by one PhD person working only on their machine in a little silo. Trying to connect that all to more of a digital source of truth that many can collaborate on will give it a higher chance of success, and also a higher chance of surviving way beyond the development stage.
Definitely. Yeah, because especially if you can get people working on a system together, it's like you don't have as much difficulty in setup, you don't have as much difficulty setting up testing. Like, everyone doesn't have their own Docker file or a different approach to get the whole system set up so they can develop, and you just manage it for them and for the team.
Take all of that way. But what you find is that lots of robotics engineers say, well, I've got it set up exactly as I want it. I've got this driver and that driver and this driver, and this is exactly as I want it. So you can still work like that. You can still have all of that.
Okay.
But we enable you then to have 10 other people also working on exactly the same setup that you've got.
Yeah. So what was the abstraction you made for that? Or like, how do you enable that kind of workflow? Because that seems like very different things. So like, I have a Docker container, I'm like forwarding my X11 or whatever it is, things so I can have visualization. How do you support diverse workflows where you have it on the device and you have it in the cloud and on the browser, or however it works?
Yeah, so we kind of see the projects of, okay, so the number one, what are the tools am I using? Then what am I actually developing? So what's our assets?
Yeah.
Are we actually creating? And then what do I want to do with it? Okay, so first of all, the toolkit that it's all just files, yeah? It's all just, so off the shelf we've got different gazebo versions and ROS distributions. You got things like SLAM and navigation and standard. So all the things that 80% of all ROS projects probably use the same basic 80%.
Yeah.
And then anything which is more specific, you can either add it to your base image if you want everyone to have it, or those are just simple, easy modules that can be added. So we then turn them into components, which are like assets. So in the same way your test environment can be an asset, or your URDF can be an asset.
Yep.
Little drivers and components can also be individual assets. So then you can say, okay, whenever I'm setting up the project, this is my toolkit, and then I'm populating it with all of these assets, which is capabilities and things to work on.
Yeah.
Okay? And that's all set up in an easy mix and match way, because we see the future of kind of the software side of robotics being more mix and match. So it's different behaviors that you want people to do.
More modular.
Much
you
more
grab
modular.
the components you want.
Yeah. And so if you encourage people to set it up that way, it's also easy for people to understand why this is in the project or not. And you're bringing it in because you want it to do a certain functionality, or you want your robot to have a certain behavior.
It's purposeful that you've added it.
Very purposeful. And then it's also easier for then when you're setting up the next project to the next project to the next project, people understand why things are there. It's not just hidden in one big file.
Yeah, for
sure. One person with a PhD's brain.
Yeah.
And all of a sudden it becomes something that's more accessible and people understand what the different things can do and then why different projects are set up in different ways. So it's also about skill dissemination, transparency.
It's more accessible.
And it's
in
about,
general.
yeah, and then everyone can learn together. And then as you're publishing your project, so for example, we have an open source project, one of the ones which might be showing in the background, and it was 3 different ways of doing navigation, all built on top of ROS. So it was to the field navigation, up and down the rows, navigation, and precision docking navigation.
Cool.
That started off as one big file, and we split it all up. So that the test environment was separate from the rover robot, which was separate, which was then all these different navigation packages. And it's all published in a way that people can go in, demo it and trial it, and then say, well, I don't need all the other stuff, but I do need precision docking. So I'm going to take that part and I'm going to put it into my next project. And we've also got 2 other research projects saying, actually, that test environment's super useful because it's got a field and it's got this. So we're just going to take that test environment and use it as an input to our next project.
Yeah, so much more composable robotics projects.
Yeah.
That's very cool. Are you leaning on Kubernetes very heavily for this? Because so it's like you pop up one Kubernetes, I don't know what they're called, like instance or...
Yeah, it's an instance. Yeah. And so we use...
For navigation.
Yeah, and we use Dockerization and we use Kubernetes. But what Kubernetes allows us to do is be cloud agnostic or compute agnostic, actually. So we use the same way as if we wanted to switch from Amazon to Azure. For example, we could also switch from Amazon to your local machine.
Yes. Oh, that's how you do it with all this. Yeah. So you spin up a cluster.
We spin up a cluster, and then you decide where do I want to run that cluster. So that integrated development environment, and then what compute power do I want to put on site? And your own laptop is one of the options. It's just a drop down.
Yeah.
My laptop, or I want to go to on-prem servers if we've connected it, or I want to go to all of these different. Yeah.
Okay, I think when is this a relatively new switch to Kubernetes or like?
No, it was always there. But I think the biggest learning we got from ROSCon last year, was being able to work locally was a must have.
Yeah.
So if you force people to only use the cloud,
they don't want to.
They don't want it for 2 reasons, 2 very clear reasons. Number one, it's extremely expensive. Why? When most of the things I don't need.
Cost, yeah.
All the compute costs, unnecessary. And number 2, my ROS toolkit doesn't work. I can't use RViz.
Yeah.
My gazebo, I've only got a gazebo viewer. I don't have my full gazebo. And they all work brilliantly on my local machine. I want my local machine. So this ability to empower the local, but connect to the cloud for both collaboration and compute is the magic circle that we've seen as being the must-have functionality for robotics adoption.
Yes. Okay. I like that quite a lot. And then so...
Don't you go for it.
What? Yeah, I know. No, it's hard. You guys have been working on it for a while.
Yeah.
Okay. That seems very cool. So what, I guess you have clusters running. Clusters have all of the different parts you might add. You might have NAD2, you have normal ROS, you might add Gazebo in. And then from this cluster, you can run it on your local machine. Can you also run some of it on your local machine and some of it in the cloud? Like if I am...
Yes and no. Like you spin up,
Yep.
but I can basically work on it in the morning and at 10 o'clock I'm save,
Yeah.
close, reopen,
Oh. Yeah, because the cluster is still running. For this
and then just reopen, but connect it then to the compute to then run the simulation cycles, for example. So the repository is always in the cloud. Then I'm taking that and saying, okay, this is what I'm working on now.
Yeah.
And when you close your simulation, it says, do you want to make changes and save to your project? And then I go back in and open it again,
Okay.
and then I can continue.
So with this, I'm a developer working on this. I have my project in there. How do I relate my development state to like my GitHub or my Git project that I'm working on for this? It seems like it's two separate version things because the cluster can have one version and the repository can have one version, or are they coupled where
The repositories are coupled.
Okay.
Okay, so your Git...
So you have a config file that sets up all the things.
So your Git repository is connected to your Asimovo project repository.
Yep.
So I wouldn't get you to save your code to Asimovo and then back to Git. No, I would get you to save your code back to Git.
And then
Asimovo. And then it will say, oh, there's a latest version that's been uploaded to the Git repository. Do you want to use that? Which is fine for code. But if I make change to my Gazebo simulation environment, that's not in Git. But that is in Asimovo. Or I've collected a big rose bag of data from the real robot and I've uploaded it into the project. That's also part of your Asimovo repository.
Yeah, you have like physical assets, or you had some names for things. Yeah. So yeah, you have your ROS bag, you upload that to the project. Everyone can have access to that.
And then everyone's got access to it. So you might be
quite a lot of things.
Yeah, so you might not be the one who wants to, you might then bring in a test engineer, or you might bring in a data scientist, or you might, who then is then taking what you're creating in simulation and working on it and giving you feedback, for example. And you're going to also do exactly the same way working between your simulation or simulated data.
Yeah.
And then running the same on your hardware and creating physical data.
Yeah.
And this also can be switched back and forth. So there's also that schema.
That's very cool. Yeah, you have a lot of flexibility because you're built on Kubernetes.
Yeah.
Okay. With all of this, so do you have, so if I have my Git repository and I have my robotics project in that, do you have good support for like GitHub Actions for this kind of thing where it's like I spin up an environment somehow and I don't know, maybe you have the action trigger something in some cluster somewhere that, or how does it work?
It's not all fully in there yet.
It's not all
fully in there yet. But the basics are in there. But Git's got a lot of nice side features that we don't have fully integrated. But if your repository is updated, then that update will follow through into the Asimovo update.
Do you mean it'll eventually you'll have it because everything will? Like when Asimovo eventually has that feature?
No. So it coordinates at repo level now, but sometimes you'll want to do something yourself, and not all of those would be immediately available in Asimovo depending on how you've built it and how you're working on it. But most people are actually doing the development in the platform. Mm-hmm. It's just then where do you save it back to?
Yeah, makes sense.
And you do that already with Git. You've got a cloud-based repository and you're kind of branching it and working on it and then merging it back.
Yep, your remote is a separate thing from your...
We're working off the same principles because all of that is best practice and known, but around also simulation environments or robot bags and results or.
Yes. So where do you think you guys are, like, where are you headed in the next few years? And like, I guess actually before that, how are you doing as a company? How is adoption?
Yeah.
How's funding? All these things.
So like our early evangelist group is not what we thought it was going to be.
Who is it?
So our early evangelist group is actually academia.
Okay.
So anyone who teaches robotics says, I don't need all your fancy simulation runners because I just want to teach 50 students
And have
get
them all have it set up really
set up
easy.
really easily. So I can take exactly what you've already built, set up my course, have 10 students, 50 students, 500 students, access it, and work off it immediately. Perfect. I can do my large research projects, which involve SMEs and companies and my researchers, and we can all work off a large, complex project, and we can all now access it here.
Version,
So
the latest version.
So for both research and also then publishing of that research, also it then increases the impact of that and the
reproducible robotics.
all reproducible robotics. So there's quite a lot of pluses. And they're like, you don't need to keep building anything else. What you've got is enough for us.
Yeah, they want it. They're very happy.
So that's really nice. The second emerging group, which is also not where we thought we would start, is hardware companies that say, I have a robot. Hardware is hard. I'm really good at my robot, but I don't want to develop my 100 use cases for it.
Okay.
What I want to do is showcase it in a way that it's easy for other people to try it before they buy it. It's easy for them to understand what my hardware is good at.
Mm-hmm. They get a simulation basically for free.
They get simulation, and it's also a digital. All of the people who buy it want to then do a digital build to then apply it to something.
Yeah.
They can then have a whole digital part of their product that's service. They can use it for sales demos. They can send somebody a remote control who can try it.
That's so cool.
That's it, by just logging into our platform.
Yeah.
And so that's another really interesting group. Really nice. And then another interesting group are people with problems. So they're like...
Everyone.
So this is people who aren't even robotics companies. I'm talking not robotics companies.
Yeah.
So these are more interesting. So this is, for example, apple tree farmers in the Netherlands. 150 of them all work. They've got a digital twin of the apple pre and post pruning. If they could showcase that to all the robotics SMEs and academic people out there who are looking for interesting problems to solve.
Oh, that's so cool.
And then I've got Boscalis, a multi-billion-dollar dredging company that just want a really good underwater simulator.
Yep.
And we can connect them with the top 5 universities within Europe who have got that.
Yeah.
So these are also really interesting so ultimately we will become, we are a solution for a company. We're solving a company's problem. We are a way that a company can get a robot to market fast because they can get 10 people working on it in a very efficient way. They can get people working on complex behaviors.
Because you have an environment you can distribute however and whoever.
The hardware companies don't have to develop all the software skills. So then you also can begin to create a bit of a digital supply chains or the apps behind the robots.
Very cool.
So people who can be really good at one thing but don't want to provide a whole solution.
Yeah.
And then there's a whole...
And they can just ship it really easy in a way that their users want or the developers
and again, they can showcase examples of their functionality, and then people can come in and give them consultancy work to do the next bit.
A specific thing, yeah.
So this kind of ecosystem play or the beginnings of a kind of development marketplace is becoming really interesting, but it's early days. And each one of those takes time to set up. It takes time
figure out the business model around it.
Yeah.
How are you in terms of funding? Like what round of funding? I assume you have investors.
So we're a spin out of a kind of private research organization. So we have a kind of convertible loan agreement with them for up to seed funding stage. So that's kind of all of last year's we got started in this year, basically. We're just getting enough market traction with initial customers now. So our SaaS platform went live last month. Cool. We've signed up Surf, so the Dutch universities can buy it through a central purchasing location, which was a big hurdle. And because then now all their students could just do a single sign-on.
Super easy.
So then it's easy.
That's great.
So then the first universities are using it, and we are part of at least 4 or 5 research projects with various partners already.
Yeah.
and our first couple of commercial customers. And all of that's happening this quarter.
That's
With
exciting.
us then opening a seed round once that market traction is tangible enough.
Oh.
Yeah.
Cool. Where are you guys based out of?
The Netherlands.
The Netherlands. Okay, makes sense. The Netherlands examples.
Yeah.
Hell yeah.
Although my accent is not Dutch, so that always confusing. Yeah.
Where are you from?
I'm from Scotland.
Scotland. How'd you end up in the Netherlands to start this company?
A tall, attractive man.
Yeah. That's so funny.
But I've been living there for 9 years.
Okay. Hell yeah. What do you think for where do you hope you'll be in a year from now?
And for us, what we are doing with this seed round is we will be asking for basically funding for 1.5 to 2 years, with a view that will take us from what I consider now to be our MVP. It's more than that for some of the customer base, but in my mind,
academics, they're like, we have enough.
it's an MVP towards more of a company-based solution.
Yep.
And I believe we need 1.5 to 2 years to fully understand the sales cycle, the buying cycle, which is long, and the stickiness.
In academia?
Proven the stickiness. No, just
in general?
even within a company, you get individuals to do it, but then you move into a kind of setting up one project.
Yeah.
And then that proves itself, and then you do more. Or you might start with a research project, which then turns into, okay, we want to turn this in. But once people are in, they're in.
Yep.
Kind of thing.
Yeah.
It
just helps so much easier.
There's that cycle, and robotics is one of these things which is moving super fast but super slow.
I know.
Super
That's a good way
fast,
to put it.
but super slow.
Yep. Very much.
And especially the mobile robotics or autonomous behaviors, it's hard. So those robots don't produce themselves overnight in 5 minutes. So these companies are all struggling financially or to make money. So we can help because we can make it more effective, more efficient, a lot less rework, a lot less time. But they also need to be able to buy into it in their decision-making process. So like for us, we would like to become the beginning of a real marketplace where academic meets industry.
Yeah.
And specifically SMEs finding really nice niche.
What's SME?
Small and medium-sized enterprise. Sorry, it's a European.
I don't know acronyms anyway.
Yeah.
Okay.
But also because most of those are presently anything under 500 people.
Yeah.
Which is basically almost all of the mobile robotics companies in the world today, and then we can grow with them as they grow. And what I would love is for an ecosystem where there's 100 really successful companies all collaborating and working on different pieces, rather than industrial robotics, which really have got 10 giants.
Yep.
There's really 10 giants which own that space.
Yep.
And I would really like autonomous behavior building and the kind of tier 2 and tier 3 mobile robotics applications that have got a bigger potential for impact in society.
I bet.
To get to market faster.
Yes.
And that's a big part of our kind of vision, is to enable the tier 2 and tier 3 more applications where people can't afford to put 5 million into the development.
Yeah, for sure.
To get it to market. So if we can find a way that they can all get to market
much faster
together and then they all grow, then that is a benefit.
Yeah. Okay, hell yeah.
Yeah.
So where can people go to learn more?
If you go to our website, asimovo.com, you can we've got case studies on there. We've also got developer case studies, which is more code-based. Or you can jump into the platform and set yourself up with a free account. And all of these ones which are showing in the background, you can basically get most of those for free on the platform. Jump in there, demo it, follow the documentation and run your own. It takes a couple of minutes for it to be spun up on the hardware.
Yep,
Kubernetes.
Yeah.
But once you're in there, you can then play with it. And anything you like, you can copy. And that can be as an individual asset or as a whole project.
Cool.
Follow us on LinkedIn to keep up to date with who we're hiring and what we're doing. Sign up for our newsletter. Also,
all the things.
All of those kind of things. But there's a lot on the website. But for this type of project, with this type of customer, try it for yourself. But if you're a company or even an individual who wants to know more, we've got webinars which take you through more of a click by click. And
teaches you, yeah.
And we also have got more specific onboarding for companies, because there's certain functionality you don't see as an individual, which as an institute or as a company you need a kind of demo for.
All right. Hell yeah. Thank you very much.
Thank you.
And our last interview, my conversation with Angelo Corsaro from ZettaScale Technologies. Hi, would you introduce yourself?
Sure. Hello. So I'm Angelo Corsaro, ZettaScale CEO and CTO. And, enjoying, as usual, the ROS conference.
Oh, yeah. So tell me what you guys make at ZettaScale.
So at ZettaScale, we define ourselves protocol experts. So we started working, actually, I was one of the person that started DDS standardization back in the days, right? And we still have like DDS offering, like Cyclone DDS.
Yep.
And then around 2015, I decided actually to leave the DDS working group, resign as a co-chair, and just start working on a new protocol, Zenoh.
Yeah.
The question might be, why did I decide to do that?
Yeah.
So, first, there were multiple reasons, okay? So, and those were based on the experience that we had on smart cities, okay? And some application in aerospace and defense that were showing two things. On one side, some of the limitation of DDS in getting outside of the, let's say, sweet spot, the kind of system for which it had been designed, to which I'll get in a moment. And on the other side, the fact that while, traditionally, there were people working on embedded system which weren't always connected, and then people working on what today we would call edge system, which were connected but closed, okay? And then, there was the cloud. But all of these were loosely connected, and we were transitioning to a world in which system more and more were spanning from a microcontroller up to a data center. Think about the robot today.
Yeah.
Right? In a robot, even like the one that lives somewhere over there, you have microcontroller, you have general purpose processor, but then this data has to flow end to end. And there was no protocol couple of getting it. Okay. That was creating lots of, struggle in our customer, frustration from me. It has no...
Like it doesn't fit. It's not...
It was ugly. You had to integrate multiple things, and even aesthetically, right, easily beautiful. And sense of aesthetics for me, it's quite important.
Oh, yeah.
Okay? And I think in technical matters, something has to be as simple as possible.
Definitely.
Has to look beautiful, elegant, right? As
For sure.
Yeah.
And if it's simple too, you can have a simple understanding of it, and then you can do a lot with it.
Yeah.
If you have a lot of complexity, you get bogged down in the complexity.
And again, it's very hard to do things that are simple because it assumes that you have deeply understood the problem, okay? So it's much easier to come up with solutions that are very complicated.
Oh, yes. Yeah. Super spiky. Lots of things.
But sometimes that's an indication that you have not really distilled
The
problem. Yeah. And you have not really captured the key, as I say, the versor, of the problem. And so getting back to the reason that pushed us to do that. So I wanted really a protocol that could work end-to-end. And there was another problem.
An end-to-end like microcontroller to data center.
Data center, yes. And the other problem was this. So in order to do this, right, there were several challenges because it means you need to be able to work on low-power network, which are very constrained.
Oh, that's the microcontrollers. Okay.
Correct. On microcontroller too, that are constraints in computing and CPU, but then low-power network are constrained in bandwidth. You need to run efficiently over the internet, right? You need to be secure.
Oh, okay. Yeah. So it's a huge spectrum of
It's a huge
requirements.
spectrum, and it's not easy because there is something very simple as which sequence number resolution do we use? Most people don't even think about sequence number, right?
That's like for you indexing, basically.
Messages, right? Okay. And
you can tell which is later.
Essentially decides how many messages you can have in flight while being able to detect a rollover. So if you're running on a constraint system, you want this number to be fairly small.
Yep.
Because that limits the wire overhead. If you're running, let's say, over a satellite link, you want to have lots of packet on flight. So you want to have a fairly big resolution for sequence number.
Yep.
Typical protocol have a fixed resolution. That didn't work for us. So in Zenoh, that's something that you can configure and it's negotiable. Every session can use a different sequence now, for instance. Okay. There are lots of protocol engineering that we did as such to make sure that we could really efficiently communicate end to end.
Yeah.
That's one point. But that wasn't enough. The other point is, as we have this kind of systems, and especially think about robots, and as soon as we start LETs that are battery powered, there's the question of where do we store the data? Because pushing the data always to the cloud requires connectivity, requires battery. Most communication consumes not so bad. Wouldn't it be great if we could keep data stored locally or as close as possible and query it from anywhere? without knowing where the data is stored. That's the other problem that Zenoh solved. Okay? And that's like, usually people discover Zenoh, and that's here I say the tip of the iceberg. It says, oh, super cool, I have a pub sub that can span end-to-end. And then they discover the rest of Zenoh, which is the distributed query, and that's where the real power, comes, and the realization comes, wow, okay?
Yeah. I haven't yet discovered that, I guess. So the distributed query, tell me a little bit about that.
Right. So the concept, it's actually fairly trivial, but the implications are quite interesting. Okay. So we have this concept of a queryable. What is a queryable? It's an oracle that it's around the network, and it simply tells that it provides data for, a given data set or a key expression, as we call it, okay? The key expression is where we're representing a data set in Zenoh. Mm-hmm. How does it provide data? We shouldn't care, but then we'll get there. And so then there is this get operation in Zenoh, which is how you actually submit a query. When you do a get, you provide a selector, how we call it. In this selector, you specify the data set and some predicates. And at that point, right, imagine the data set that you're specifying, it's really, logic, like a mathematical set.
Yeah.
And in that case, what Zenoh does,
it narrows it down.
It looks at the set you're looking for. It does a set cover with respect to the queryable that are on the network, and then decides what is the optimal set of queryable to which we need to route the query in order to get your data. And the consequence is that you don't need to know where the data is.
Yeah.
Depending on where you are on the network, we might route the
pretty magical. Yeah.
To different queryable.
Yep.
So that supports natively mobility, load balancing, and fault tolerance without you even thinking about it.
Amazing.
And then, if you think about a database, right, the combination of a subscriber and a queryable is the reading and writing side of database. And that's how we integrate database in Zenoh, like, Amazon S3 or RocksDB or InfluxDB or whatever. And a computation is just a queryable. And now, if you think again for a moment, map reduce. Okay, what is map reduce? You want to get a computation trigger on multiple nodes, and then you want to consolidate the result.
Yep.
But you can achieve that with queryable, because you can have multiple queryable essentially responding the same query, operating a different subset of the data, and then when the query is computed, we consolidate the data back Audrow.
Oh.
So all of a sudden, in one protocol, you can deal with data in motion, pub sub, data at rest, so storages, and computation in a completely location transparent manner.
In a completely what?
Location transparent manner. So you do not.
What do you mean by that?
You do not need to know where the data is, where the computation is.
Yeah.
And as a byproduct of our routing algorithm, depending on where you are on the network, you are always going to pick the optimal place, either to get the data or to trigger the computation.
Yeah, that's so cool. Thinking of it like a distributed database is a very cool way.
That's the
that has all the computation, then it routes it all.
Correct. And we also have storage alignment. So imagine that the network gets partitioned.
Yeah.
If you have different storage, then whenever the network heals, the storage are realigned automatically.
Wow.
We have a pretty cool algorithm. And so that's the bottom of the iceberg that usually people discover that
later.
Once they realize the full power of it, they say, wow.
Yeah. I see it. Okay. With this, how does it work? Like, I know it sounds like it's very complex. You have this very amazing networking.
The protocol, go ahead.
How does it, like, at a high level, how can I understand what's going on that leads to this really nice routing behavior and synchronization?
The underlying protocol is actually quite simple. And I think what allowed us to make it so simple is that we really narrowed the key primitives, okay? And in the end, what we do, right, we just route key expression on the network, right? So, and there are some technical, let's say, complexities on how to make this efficient, but the key concept are actually pretty straightforward, right?
So when you say key expression, what does that mean? Is that like a function?
No, imagine a ROS topic, right? Yeah. Like CMDVAL.
Okay.
That's a basic form of the key expression.
Yep.
Now imagine that I have multiple robots. I could say bot1/bot1/CMDVAL.
Yeah.
So that's a key expression for us. It's a full key there are no wildcards, that represent just one data item.
Okay.
If I have multiple robots, I could say bot star / cmdevel. So imagine that now...
so you can have wildcard queries in it.
So whenever you have wildcard...
And you could probably do some filtering.
Correct.
So, that's super cool. Okay.
So, because essentially when I talk about key expression, you realize because of wildcard, all of a sudden you're representing a set of keys as opposed to a single key.
Yep.
And you can do that on subscription, right? Because maybe I want to receive the SumDebel from multiple robots.
Oh, that's so powerful. Yeah.
And in query, because imagine, right, I want to know the battery state of all my fleet of robots.
Yeah.
You could do get, right? You don't need get /bot star / battery level.
Huh.
That would trigger a distributed query.
Yeah.
And get the data to you. Now, where is that data? Well, it
could be in a bunch of nodes.
Might be on your robots.
Yep.
Might be stored in a cloud, and you are closer to the cloud. Because imagine I'm by the robots and I do the query. Maybe the fastest way to resolve it is straight on the robot. If you are, in California and the robot is here, and the data is also stored on a storage, on a Google Cloud.
Yeah.
The closest storage will be on a Google Cloud.
Yep.
Do you need to care? No. And that's great, because you don't care what it is. You care to get the data, don't you?
Yeah. I guess I don't fully understand how it's working from this. So that seems wonderful.
Yeah.
And so you get to not care about where the data is actually stored.
Yeah.
Okay. So continuing, I guess, with the explanation of how it's working, like, I guess conceptually, what we're...
Okay, so... conceptually with respect to how we figure out where the data.
Exactly.
Okay. So essentially in a Zenoh system, you have to think that we reconstruct a graph, okay? And over this graph, imagine that we have annotations like on a road.
Your metadata at each node.
So let's make an analogy with when you're driving, okay? So when you're driving, and that's one of the way in which we make discovery very efficient.
Okay. Yeah, this is exactly what I want to try to understand.
So suppose that you are going from San Francisco to Santa Monica, okay? So where do you look as a first indication? You look LA potentially, right?
Yeah.
So right,
and once pretty close.
And once you get to LA, you look the road to get towards Santa Monica.
Yep.
And the way to make this efficient, right? You don't get all the details in your mind, right? You refine it the closer you get to your destination. This is exactly how Zenoh works, okay? So imagine that now you have a graph that represents Zenoh nodes. Those could be infrastructural nodes like routers or application.
Yeah.
And we reconstruct a graph in which, like in the analogy that I made with the road indication, we have a generalization of this code information. So like in the case of the bot star cmdevel, or bot if you want to get the battery status of a specific robot.
Yep.
Okay. Then at every hop we will know how to route your request, and this gets refined. And the closer we get to the target, the more detailed information we have on how to route it. I know this still sounds vague, but that's really how it works.
That's what you're doing.
And this is how we manage to really consolidate discovery. People often say, we have problem with DDS discovery. If we make an analogy, in DDS, everyone has to know everything about everyone else.
Yes.
And that just cannot scale.
No.
Right? In Zenoh, the point is that you don't need to know anything about everyone else. Maybe you just need to know that if you need anything from bot 1, that's that way. And bot 2 is that way. That's intuition.
Yeah.
Okay? And then in terms of mathematics, because there is some mathematics behind it, it's all set theory. It's set theory generalization. There are also some algorithms that we use in terms of equivalence between regular. So there is some complex math behind, but then the result for the user, it's easy.
Yeah. Oh, so cool. Yeah. That you have is it like, it's almost heuristic based. Go that way first. You're going to go to LA first, and then you go to Santa Monica.
So you could use heuristic. But in our case, it's not heuristic, it's generalizing.
Yep. Because they're doing that theory that you're
Exactly.
And so
in a way, you can think about it as every time, the more you get further away from the source of information, right, the more you have a generic description of the data set that is behind.
Yeah.
Okay? And because again,
follow it a little closer.
One zillion application that way, right? And if all the detailed information about one Zenoh application gets to me, I get overwhelmed with data. If I generalize this information, right, and I get a distilled version, right? I know this sounds abstract, but literally this is what we do, okay?
So cool.
And that's the secret of the product.
Yeah, and that's why it's aesthetically pleasing, because you have this general approach that lets you get these very powerful results and then handles a lot of the like tricky cases where you can synchronize your data and things like that.
And again, and the user doesn't need to think, right?
You have a simple interface to work.
Simple abstraction. And something else that sometimes is missed, right? So we've been talking about, both one CMDevel. That's how usually ROS topics are called.
Yeah.
And they are mapping to what we call Zenoh resources that are also string. And then you also hear us telling, well, but we have, just a handful of bytes of wire overhead. So how does the two
work? Yeah.
Right? Because if you are using string, only that string is more than a few bytes, and that's not the data. So in Zenoh, there is an automatic mapping of key to small integers.
Yeah.
This is done automatically, and it's unique within a session. So if you and me are communicating, I will come up with a mapping that maybe I will be using only with you or maybe with everyone else. It depends on concurrency, right? Because maybe we map the same key to different ID, which is perfectly legal.
As long as it's local to that one
and
node.
as long as I know that it's your mapping.
Yep.
And that's nice because you get the wire efficiency and you get the user experience.
Yeah.
Because, there were other technology in which you could map integer to keys, but then you had to, as a user, to keep dynamicity, which is not scalable in large-scale distributed systems.
No, lots of errors, probably.
Exactly. So once again, usability, right? User-friendliness, but then the magic behind to make it efficient. And that's, I think, that's ZettaScale approach in a way.
Hell yeah. Super cool.
Yeah.
So how, what problems explicitly is this solving from DDS? And then also, how, we're very excited about this as a ROS2 community. I would love to hear a bit more about that too.
Yeah, so I think there are a couple of problems. First of all, as of today in ROS, there is not a single solution to go from the microcontroller up to the data center.
Very true. Yep.
Why? Because you have to use a protocol on the microcontroller, which actually is not DDS, because XRC is another protocol. It's a client-server protocol. Then you have DDS on inside the robot. A DDS cannot cross the internet. So you have to use something else, and that's why, there is the MQTT bridge.
Yep.
So that's already nice because you will have one protocol you will use end-to-end, and that's great. Okay. So that's one problem. I think it's very important in terms of performance, streamlining, monitoring your system, right?
Yes, definitely.
I mean,
every bridge you cross.
Exactly.
It's harder and harder.
It's a mess, right? Yes. Well, I call that a digital Frankenstein.
Yeah. It makes sense. It's like spliced together.
It's a digital Frankenstein,
Yep.
right? Yeah.
Good way of putting it.
Yeah. And so that's one problem. Second problem is the discovery, right? So we've shown, and this has been reproduced by user, even if you take a simple Turtlebot and you make comparison with Wireshark, we reduce off-the-shelf discovery by over 90%.
Wow.
That's huge.
That's amazing.
And again, that's because the protocol works very differently, as I just explained.
Fundamentally different. Whereas DDS everybody has to know about everything that pops.
And again, you tell me everything about yourself. Maybe I don't care. Just tell me your way. And I know that if I need something, I have to
go for you. Yes.
Yeah, that's how Zenoh works. It's like, cool prem, man.
Yeah. Cool.
Okay. So that's the discovery point. We discussed the connectivity. And then there is another point. So the queryable are being used today to efficiently map services and actions. So even today, during the presentation from Chris on the status state of the house, is known that when you use different DDS vendors, there is no interoperability or they have problem with services. Why? Because of how DDS works, DDS doesn't natively support remote procedure call, is built on top. But again, for how DDS works and how the DDS standards are specified, there are some gray area that make it very hard, right, to have vendors have the same behavior.
Yeah.
In Zenoh, queryable are built in. Queryable is a generalization of RPC, okay? And that is used to very efficiently map services, increase scalability, increase determinism too. I think that's quite important. And then something else that is not there yet, but I mean, at least soon. I would really like to see it soon, is true zero copy in ROS. So Zenoh has built-in support
Or, okay.
Yeah, Zenoh's, no, a cross-processor.
Oh, okay. That would be amazing.
Yes, Zenoh has built-in support for shared memory.
Yep.
With the 1.0, we also have now the ability of plugging in shared memory provider. So if you have custom hardware like, GPU,
Yep. NVIDIA or something.
you can plug a provider for that shared memory, allocate out of that buffer, and then if you're using Zenoh, all is transparent.
Yep.
So we would like to have this model exposed also to ROS programmer.
That's awesome.
Because then we could really have true zero copy, zero serialization would be gorgeous.
It would be gorgeous.
Yeah.
I love it. Hell yeah. You clearly love this too, which is
I do.
wonderful.
I mean, that's my passion. And then there are some other stuff we are doing around video.
Video.
To facilitate, yes.
Oh, with
Video is very
compression and
close,
things like
that's
that?
very close to my heart too. Yeah.
Okay, I'd love to hear a little bit about that.
Yeah, I mean, again, it's facilitating the sending of and transparent compression because we already do transparent compression in Zenoh. And it's just going beyond and supporting that knuckle.
Yeah, because video has its own compression algorithms.
And there are some peculiarities that
Definitely.
you will see something happening soon.
Oh, I can't wait. One thing I would also like to hear about. So Zenoh.
No, well, you can use both.
Okay,
So should we talk about this?
sure.
Okay, so the name of the protocol.
Yeah, where'd it come from? You were mentioning it at
So
the start.
the acronym means zero network overhead. Okay. Now the H, so the H is the O and H. So here zero network overhead. Okay.
Yep.
Now in reality, the protocol had to be called like this, just Zenoh or with an N. Okay.
Yeah.
But with an N sounds kind of strange.
Yeah, it does.
Because people
Seems
would
alien.
call it Xenon,
Yeah.
but that's not how you would pronounce. And the domain wasn't available either. Okay.
It's pragmatic. In our current minds, you need it.
The question is, why Zenoh? So there are two philosophers that are very close to my heart.
Okay.
One pre-Socratic, that was the philosopher about the paradox with things that were getting almost close to zero. Zero network overhead is not possible, right? Can be as
Loves it.
yeah,
Very poetic.
right. And I mean, he's a pretty incredible philosopher, which
Oh, yeah.
I like a lot, and kind of inspired this idea of getting as close to zero.
Yep.
And the second one, which I think it's also a source of inspiration for me, is the father of Stoicism.
Oh.
Okay,
Oh, yeah.
and which is all about the perseverance, doing things properly, right, and making a
Yeah,
positive.
the good work.
Exactly, because that's what give you euphemia, which
Yeah.
is essentially the accomplishment and the happiness in life.
Yep. Yeah, that's how I think too. It's all process.
It is, yeah, and again, it's this commitment to always improve.
Yep.
And I think that's what's beautiful, right?
Oh, yeah. So the father of Stoicism,
Zen,
Zenoh.
yeah.
Ah.
And then obviously for me,
Marcus Aurelius.
Marcus, absolutely, Seneca, yeah. But the founder is Zen.
Cool. I love
Marcus Aurelius, yeah. Have you read the Meditations? Great, right? Yeah.
Yeah, amazing. And he didn't even intend to write it for anyone.
Yes.
So crazy.
Yeah, yeah. If you haven't read it, you should read the Meditations. Yes.
So, yeah, recommended. Yeah. So that's super cool. Okay. And then I'd love to hear a bit about so you guys are using Rust for Zenoh.
Yeah, absolutely.
Rust is awesome. I really like Rust. It's not something that's been common for Rust too. So we're having to add, to support Zenoh as like a first class middleware, we are having to add a lot of tooling around Rust because Rust has a very different philosophy of how package management works to C++, Python. So I'd love to hear a little bit about
Why Rust,
and then kind of how it's been going to integrate in with Rust.
Okay. Yeah, so the first version of Zenoh, the very first version of Zenoh was written in OCaml. Have you ever heard about OCaml?
Yeah.
Okay. So, of course, we are based in France, right? So, yeah.
I don't know too much about OCaml. OCaml, was it kind of like TypeScript in some sense? Or
So OCaml is a variation of ML, which is one of the key,
Yeah.
And if you look about the programming language, on one side you have Lisp,
Yeah.
and it's like one family. On the other side you have ML, and it's another family.
Okay.
And then the most popular version of ML is actually OCaml, which was done in France.
And that's an ML in it, maybe OCaml. Okay.
Yeah. And so OCaml, again, why OCaml? Because we care immensely about security. Okay, so OCaml, obviously, it's a language for which there is a very sound type system. Memory is managed. And by the way, there are things like coq, which you can use to prove certain algorithm. So in the very first implementation of Zenoh, we had proved certain element with coq. Okay. Again, it's France, okay? Yeah. And around us, we have lots of formal method guys. So we had some collaboration with Sewa, was gorgeous.
Yeah.
We also were a smaller team, and we need productivity.
Yep. So you
something
move
that
fast.
gets deployed on the network. We want to make sure that we don't have 70% of the source of attack, which are related to memory mismanagement, are solved. And there were some unikernel really focused on security, built on OCaml, and that could host OCaml. So we were deploying Zenoh also as unikernel, as network appliances, which was super cool.
Yeah.
Then we started pick up, and especially we got users in telecommunication, which they told us, guys,
can't write no
OCaml is nice, but besides in France, in Yale, and in Cambridge,
no one.
Where do you find OCaml program? You said, in the financial market.
Oh yeah.
They are very expensive programs.
Oh, I bet. Because they're coming from finance.
And so they said, you have to move to another programming language.
Because Rust of all the...
So actually Rust we had already evaluated when we did the first writing. When we did the first writing of Zenoh, but that was before the 2018 edition. Okay.
Did it come a long way? Because I think over the last 4 or 6 years, it's really grown up.
For the 2018 edition, we felt, it was too much of a stretch. And then, when we started the open source project and we did the rewrite, it was just before 2018, but the pre-release of the 2018 was there. We did an evaluation and we went for Rust. And honestly, it has been gorgeous.
Rust is great.
Memory safe, concurrency safe, so we have similar guarantee than OCaml. Much better performance.
Oh, so bad. So
terrific tooling ecosystem.
Yep.
Right. And the other reason why we're choosing Rust is because you can run bare metal on microcontrollers.
Yes, very true.
So we have already, if you look at our code base, there are bits and pieces of Zenoh that are already no STD.
Wow.
So eventually, you will have the
whole thing. Yeah.
Core of Zenoh, no STD to it. Yeah.
That's awesome. So you can support microcontrollers very easily in the same code base, and you just have the code path.
So today we support with C, but eventually, because microcontroller is still heavily a C, C++ ecosystem, but we have more and more requests about Rust, and we'll be getting there.
Yeah, I've tried Rust for microcontroller programming, and it was a little difficult as a process, harder than C.
Well,
for this kind of thing.
They are getting there. That's an interesting project. But again, the experience with Rust has been quite terrific so far.
Yes.
Obviously, the edition continued to evolve. We were probably one of the earliest users of async.
Oh, yeah. Now it's come a long way.
That has come a long way, and I think we have grown with it. Okay. But, I don't regret the change. I think the team is active. In terms of productivity, we see the difference.
Nice. Yeah, Rust is great.
Yeah. And then, in terms of integration in ROS, I would say great thanks to the Open Robotics team, right? Because they are doing the heavy lifting for us. They're pulling out Zenoh as it is, right? Integrating it. So in that respect...
And all the build farm work, which I think is the bigger part of all of it.
I know that, folks like Steven would like to change a few things, and in due time they will.
Yeah.
But I think it's working fine right now. And, great thanks again to the work of Open Robotics for that. Yeah.
Hell yeah. So where do you think you'll be, or when you look forward for the next, say 1 to 3 years?
Yeah.
Where do you think you guys are headed, and what do you hope for ZettaScale?
So, first of all, continue to do great innovation and great work in addressing user problems. Because, I always say, to all the Zettlers, that's how we call ourselves, we are here
Zettlers.
Because of our
Zettlers. That's great.
Correct. Zettlers, yes.
Love it.
Because of our users, right? So our goal is to solve their problems. And, we have grown, but we don't want to grow like crazy. We still want to grow organically.
Yes.
Maintain our culture, maintain, very high quality. We're expanding in new domains. So we are, it probably will get public, but besides automotive and robotics, we are seeing application medical,
definitely
traffic control management.
Yep.
In avionics,
microcontrollers and computers.
And by the way, you don't know, but we are already deployed in 3 blockchains.
Wow.
Okay.
That's so cool. So that's really cool. You're seeing it in Spain.
So I think we'll continue to expand in terms of market. ZettaScale will continue to organically grow. We have now a platform. We are going for certification. And so I think that now ZettaScale, it's kind of felt like the new innovative kid around the block. And I hope that in 3 years, it will be understood that we are the place to go, right?
Oh, yeah.
To get people that listen to you, that like to generally solve problem, and that, as I always like to say, they will be here in good and bad times. Because that's a big difference.
Yeah.
And that's also stoicism, right? The big difference is, who you can count when our time counts. And I think that because, sometimes there are always challenges.
Yep.
And you want to choose your partner properly, and we are one of those partners.
Oh, yeah. I love it. All right. Thank you very
It
much.
was my pleasure. Thank you very much. Yeah.
Thank you.